Hello, and welcome to Backer Breaks It Down. So, I would like to talk to you today about chords and arcs. Now, take a look at this little comic here, right? Because this is illustrating one of our main ideas today. Okay, and so this is a foxtrot comic, and clearly Paige is upset that she has to study math in school. Okay, and of course, like her mom's busy doing something. And her mom says, I need to cut this quiche into 5 equal pieces. So Paige is like, give me one example when I'm ever going to use this junk I'm learning in geometry class. Just one. Let's see. 1/5 of a circle is, just cut it into 72-degree wedges and listen to me, mother. Yeah, she just unknowingly did some math there, but where did she come up with the 72 degrees? Okay, so, her mom was talking about a quiche, right? And she said it's 5 equal pieces. So got our circular quiche, got our 5 equal pieces. Okay, like bear with me here. I have to draw like 5 equal pieces. That's pretty good, right? So where's she coming up with the 72 degrees? Yeah, so in a circle, if you go to like all the way around, that's 360 degrees. Okay, so if you divide that by 5 equal slices of quiche, right, then each of those angles there, sorry, my pen's not working, is 72 degrees. Yeah. Okay, sorry. You get it though. So some vocabulary here, and you've seen these terms earlier. A central angle is an angle whose vertex is at the center of a circle. Okay. A semicircle is an arc whose endpoints are the diameter of a circle. A minor arc is an arc that's smaller than a semicircle. So a semicircle basically divides the circle into 2 equal parts. Each part would be like 180 degrees. So a minor arc has a measure less than 180 degrees. Minor arcs are named using the 2 endpoints of the arc, and the arc measure is equal to the measure of the central angle. So going back to the quiche slice, like the central angle, I think like I don't know if like you thought the 72 degrees was the measure of the angle or was the measure of the arc. Most likely you probably thought it was the measure of an angle, because who knew arcs were measured in degrees? But if you think about it, one full circle is 360 degrees. And would you really consider like the distance around a circle as an angle? I don't know. Anywho, so in the diagram on the right, AB is a minor arc. Notice how they're naming it, right? And they are including like a little arc right above those 2 letters. A major arc is an arc that's larger than a semicircle. We name it using 3 letters, the first and last being the endpoints and the middle being any other point. That way we know like where does our major arc start, what does it go through, and where does it end. So that's why we're using 3 letters to name a major arc. So they're calling the major arc in our diagram arc ADB. And so basically we can find the measure of that major arc by simply going 360 minus the minor arc associated with it to get 250 degrees. Okay, here's another example of how they're like coming up with the measure of a major arc. So in this diagram here, I note that arc XY has the same measure as its corresponding central angle, so it would be 72 degrees, which means the measure of the remaining major arc, so arc XZY, would be like 360, because that's the whole circle, minus 72. And so it would be 288, and that's what they're got here, okay? So example 1, apparently we're not to example 1 yet, sorry about that. Congruent arcs. In the same circle or incongruent circles, 2 arcs are congruent if and only if their corresponding central angles are congruent, so that kind of makes sense. Adjacent arcs. So we, like last semester, worked with adjacent segments. So now we're just working with adjacent arcs. They're essentially the same thing. They're just arcs and not segments. But we have an arc addition postulate, which basically says if I add two smaller arcs together, I'll get a bigger arc. And that's what like this diagram over here is illustrating. So if I add arc AB and arc BD together, I'll get arc AD. Yeah, makes perfect sense, right? All right, now example 1 through 4 really, because 1 through 4 are using circle Z, and notice that in circle Z, we know that angle UZV is 155, so that means its corresponding arc is also 155. Angle WZV is 46, so its corresponding arc is also 46. We know that arc XW would be 38. We know arc XY would be 55. Okay. So knowing all of that, what would be the measure of angle YZU? Yeah. So basically, if we go 360 minus those 4 given central angles, we'll get the measure of YZU and its corresponding arc. Both are 66 degrees. Find the measure of arc VXU. So VXU would look like this. Starts at V, goes through X, ends at U. So notice it's basically the circle minus arc UV. You see that? So if I take the entire circle of 360 and I subtract this arc here of UV, I'll get the measure of arc VXU. So 360 minus 155 is going to give me 205. The measure of arc XU, so let's identify that arc. X and U. Notice X and U is the combination of 2 smaller arcs. You've got XY and YU. So if I add those 2 arcs together, I'll get the measure of arc XUs. So I'm adding 55 and 66, and that gives me, oh my goodness, 121. And then finally, find the measure of XVU. So this is different than number 2. It seems similar because they're using like the same 3 letters. But arc XVU, let's see what color have I not used yet. So here's X, goes through V, and ends at U. So notice it's the major arc in which X used the minor arc. So we can just do some subtraction to get that. And so we're getting 239. So 1 through 4 is just a matter of using that basic relationship that the arc measure is equal to the measure of the central angle. And then we have to use some like arc addition in some of those problems. Problem number 5 brings in some algebra because, of course, can't go abandoning those skills, right? Number 5 says to set up and solve an equation to find the value of x, then find the measure of SQ. So if you look at the diagram, notice that they have basically given you everything that you could possibly ask for. They told you that arc QR was 140, right? They told you that angle, this angle here is 4x plus 21, but you know, the arc would be the same. And then that third arc has a measure of 13x plus 12. So if I go and add all 3 of those arcs together, I'm going to get 360 degrees. So I've already done this math for us to save us some time here. So that's me adding all 3 arcs equal 360, simplifying, solving for x. I got that x is 11. And then they wanted me to find SQ. SQ is the arc given by 13x plus 12. So plug 11 in for x, calculate, that's how I got 155. Okay. So the measure of an arc is equal to the measure of its central angle. And there's 360 degrees in a circle. And that's how Backer breaks it down.